OSFDP on Advanced Communication Lab. We are going to see about microwave lab. We have different type of band of frequencies to say X band, J band, K band, R band, L band, like that for different applications. Normally for electronics and communication advanced microwave lab, we have got X band microwave setups by using two type of sources. One is klystron source and another one is gun source, to study various modes of experiments like characteristics of klystron, characteristics of gun diode, attenuation measurement, lambda measurement. Lambda measurement is nothing but the wavelength measurement. Then we have got scattering parameters of E plane T, H plane T and magic T. Then we have got coupling factor and directivity of multi-hole directional couplers. Then gain of the horn antenna and the radiation pattern of pyramidal waveguide horns and parabolic horns. Different type of horn antenna studies also we can do. We have VSWR measurement by measuring known values, unknown values, infinity values by using match terminations, movable charts and movable chart with SS tuners, and some samples like Teflon, nylon, ebonite, wax, perfect, ceramics and fabrics for our experimental study. And we have these are the experiment normally we are using in ISRO, CDOT, LRDE, Air Force, Indira Gandhi Center for Atomic Research, CSIR, IIT, RSIC and all communication labs in engineering colleges, and also Air Force Technical College we are using. We can study the DRDO and also LRDE projects also we are doing with microwave studies. In our microwave lab, normally for the electronics and communication students, we have klystron setup, consists of klystron power supply, klystron mount, klystron tube, along with the cooling fan is called klystron source. We have got, after the source part, we must have one controlling unit to control the power by way of attenuation, so that we are using variable attenuators which creates 0 to 20 dB attenuations, so that along with that experiment we can align the power by using the variable attenuators. Component, it's called direct reading frequency meters, to measure the frequency what you have tuned in the klystron source can be identified by this particular component. It's called frequency meters. We have got two type of frequency meters. One is micrometer type frequency meter and another is called direct reading frequency meters. After the measuring instruments, we are having one more instrument called isolators bar circulators, to control the reflection factors from the source part towards the source also can be avoided by using the isolators bar circulators. And we have got one more section is called slaughter section with probe carriage. With that we can study the lambda measurement and also VSWR measurement. On the top we are going to feed one component, it's called tunable probe. And after the slaughter section with the probe carriage, tunable probe, we are going to additionally we can add one more component, it's called detector mount. The difference between the detector mount and tunable probe, the detector mount, what are the results you are going to get is a direct signal from the source, and what are the signals you are getting from the tunable probe is reflected from the loads. So these are the experiments we can do by using the output sources to measure oscilloscopes, or also we can use the power meter with along with thermistor mount sensors, and we can have VSWR meter and dB scales. Ordinary multimeters also can be used by way of DC level shifts and other things. So this is a simple experiment we can perform with the microwave studies, and we can do lot of projects also by measuring the dielectric postulate for solids and liquids, and also safety research institutes, security systems. All these places we can use this particular microwave benches. According to that, we are having here X-band microwave setups which consist of 8.2 to 12.4 GHz and the power rating of 100 milliwatt power by way of klystron. And it depends upon the different type of band of frequencies, to say L band, which we are using in microwave ovens, and we are having K band, K band, C band, R band. These are the things we are using for our telecommunication purposes. and we are using some more components and other things for designing the antennas and other things also we can do. It depends upon the, when we talk about the antennas, we have got E sectoral horns, H sectoral horns, pyramidal waveguide horns, parabolic horns, narrowband antenna, wideband antenna, and also different type of antennas. And recently we can invent that MIC patch antennas. That's a microwave integrated circuit antennas with multi-elements. For example, single element, 2 element, 4 element, 8 element, 16 elements. Depends upon the elements, we can have the sources of output can be gain also can be increased. So these are the things we can use it. Additionally, we can perform lot of experiment by using this. Thank you. We are mostly supplying to all the engineering colleges, more than 7 engineering colleges in South India. Apart from that, research institute, especially for PSNA engineering college, we are supplied past from the beginning of the college. We are regularly supplying to the PSNA engineering college with very good reputations, and we are maintaining the systems and other things. This is one of the leading engineering colleges which doing a lot of projects in electronics and communication department, especially for microwave labs under the supervision of the HODs and principals. Apart from that, we are also coordinating for past more than 20 years to them, and we have PSNA is having excellent lab for study of microwave electronics and communication department. Thank you very much.